Okay, this is the practice test number 3 out of a study guide that they gave me to, use for this course. I hope you took the practice test number 2 before this course really started, so you can kind of compare yourself between then and now, but if you didn't, no big deal. So please work this yourselves first and then watch me work through it, okay? It'll be better if you certainly give it the old college try yourself, all right? But here we go. This will probably take 2 videos for me to get it all done. Number 1, how many 2 1/4 fluid ounce bottles can be filled from a bottle that contains 9 fluid ounces, okay? Sounds like a division problem to me, doesn't it? I really need to take 9 and divide it by 2 1/4. Okay, now we've divided fractions. I talked about how to do it on the calculator, and I'll do it quickly both ways. I'll think of that as 9/1 divided by 2 1/4, and I'll turn that into an improper fraction, so that'll be 9/4, which is really 9/1 times the old flip-flop, right? 4/9, and you see the 9s kind of conveniently fall away, and we're going to cancel out, we're going to get a 4. Okay, so number 1 is going to be part D, 4 bottles. How do we do that on the calculator? Yours, of course, is a little different, but 9 divided by a mixed number of 2 1/4, right? 2 fraction 1 fraction 4 equals 4. Okay, here we go. All right, straight up adding fractions here. I'm adding mixed numbers, I should say. Again, my best way is to clear out those mixed numbers. Turn them back to impropers, so it's going to be 7/4 plus 12, 17, 17/6. Okay, so we have this dilemma of a common denominator to figure out, right? What's it going to be? Between a 4 and a 6, it'll be a 12, right? So I'm going to multiply this fraction by 3/3 and this one by 2/2. So that's going to give me 21/12 plus 34/12. And I'm going to add those together, and I'm going to get a 55/12, aren't I? Everybody cool? Everybody with me? Turn that back into a mixed number. How do we do that? Old school longhand division. Well, 12 goes into 55 4 times. That gives me a 48. And then I do the subtraction. I'm going to get what? I'm going to get a 7, right? So it's going to be 4 7/12, which was answer A. Okay, again, you do have a fraction button on your calculator, so might as well use it and save time. Okay, it's all about time with this test also. 1 fraction button 3 fraction button 4 plus 2 fraction button 5. Oh, I screwed it up. I felt myself hitting an extra key. 1 fraction button 3 fraction button 4 plus 2 fraction button 5 fraction button 6 equals, what do we get there? 4 7/12. We got it. Okay. Alright, decimal. Alright, you line up the decimal, right? Let's just rely on the old calculator for this one, but we could do it. But you line up the decimal, you might have to borrow and all that stuff. Subtracting 873.65 minus 24.344. What are we going to get there? 849.306. Looks like choice B to me. Okay, all good there? Alright, dividing decimals again, longhand division and all that stuff, When you have this number out front that's a decimal, you can correct it. You can shift it 2 places to the right, and you shift that 2 places to the right. So now it's like you're trying to do this problem. Okay, it's not quite so bothersome because the decimals are all gone, right? I mean, the decimal's here, right there. But it's like a regular division problem at that point. But again, with our calculator, decimals aren't a big deal. 50.29 divided by 0.47 equals, what do we get? 107. D. Alright, sweet. Okay, another fractional problem. 4/5 divided by whole number 4, which I'm going to call 4 over 1, okay? This one's easy enough that I'll just do it by hand because I'm going to turn it into multiplication and do the old flip-flop, right? And then the 4's cancel. And all we have left is 1/5. All right, so all good there. 1/5. Okay, I'm digging it. Let's proceed. All right, number 6. What does that say? A tablet contains 2 and 2.25 grams of aspirin. If a patient takes 2 tablets every 4 hours, how many grains of aspirin will be taken in that time? All right, we got to stop and think about how these things are worded sometimes. Okay, pardon me as I fumble around here over here. Each tablet contains 2.25 grams of the aspirin, and we're going to take 2 tablets every 4 hours. So how many grains of aspirin will be taken in 24 hours? Okay, well, let's figure out about this, how many we're going to get just in these 2 tablets. Okay, so we've got 2.25 grains in 1 tablet, and we're going to take 2 tablets. So, quickie here, 2.25 times 2. Right, that gives us 4.5. That's grains per, let's call it per dose, because I'm taking 2 tablets at a time, okay? Well, I want to do that every 4 hours, okay? And I want to know over a 24-hour period how many grains I'm going to have there. So how many doses am I going to take in a 24-hour period? I'm taking them every 4 hours, so that would be 6 times, right? So I'm going to have times 6 doses. The doses are going to cancel. I'm only going to have grains left as a unit. So I'm going to take 4.5 times 6. And what do I get there? I get 27. Okay, think it through. We were given grains in a single aspirin, okay, but then we were told we're taking 2 tablets every 4 hours. Now they're switching terminology. Aspirin and tablet, we're supposed to know that's the same, and I think everybody would know that's the same, okay? So just be real careful about the information you're given on a problem like that. We were only given the information about 1 tablet. We're told we're taking 2 tablets, and now we're doing it multiple times a day, and we want to know what's happening at the end of that day, okay? So just caution with the way things are worded. All right, number 7. A dieter lost 2.4 pounds during the first week, 3.5 pounds during the second, 2.9 during the third, and 3.0 during the fourth. What was the average weekly loss? Okay, so we're just going to take a simple average here. That shouldn't be a huge deal, right? We're going to take 2.4. Okay, these are all pounds here, so I'm not going to write the units. Plus 3.5, plus 2.9, plus 3.0. 1, 2, 3, there's 4 of them, so I'm going to divide by 4, and I'm going to get some number when I do that. Let's see what we get here. 2.4 plus 3.5 plus 2.9 plus 3, okay, 0.0 equals, we're going to get 11.8, but then I got to divide by 4, and I'm going to get 2.95. Is that what that says? 2.95. Okay, so C, 2.95. Alright, another fraction division. Boy, they really, they're merciless with these fractions, aren't they? Let's do this one on the calculator. It's easy enough to do either way. 5, fraction button, 6, divided by 1, fraction button 3, equals mixed number 2.5. Now maybe that's not going to be a choice. That is a choice. But maybe they would have only given it to us as an improper, right? Then it would have been 5/2. So we got to pick up on that and see how the answer is given to us. But, okay, as it turns out, we were given the mixed number form. All right. What's the maximum number of 1.5-inch strips of tape that can be cut from a 480-inch roll of tape? Okay, well, you know what we're going to do. We're going to take this big, long thing. We're going to cut it in a bunch of strips. How many? Well, it depends on how long each strip is, right? So it's a division problem again. 480 divided by 1 1/2. Okay, again, we could go through our denominator there, and we can call that improper and flip it over and all that business, but again, in the interest of time, let's just do the old calculator here. 480, got to type it in right, and I can never see what I'm typing unless I look at my computer. Okay, divided by 1 fraction button 1 fraction button 2 for 1 1/2 equals 320. Beautiful. Okay, hopefully no issues with that one. Alright, an income tax system requires that a person having a net income between $10,000 and $16,000 pay a tax of $800 plus 24% of that part of the income in excess of $10,000. How much tax should be paid on an income of $12,500? Alright, so it's kind of like a two-part problem. You might have to read a problem 2 or 3 times to make sure you understand what you're being asked here. The income tax system requires that a person having a net income between $10,000 and $16,000, okay, so we're going to fall into that category. We have to pay a tax of $800, flat tax, okay, plus 24%, but 24% of what? Of the portion of the income that's above $10,000. Okay, so we make $12,500 here, so we're going to have to pay $800 for sure. Okay, but then we're going to add to that 24% of something, but that something is only the amount I'm earning over $10,000. Okay, so I'm earning $12,500, so that's going to be $2,500 is going to be the difference there, right? So that's going to be my little problem there. 800 plus 24% is 0.24 times 2,500. Okay, so again, you could type this whole thing in the calculator in one shot if you want. 800 plus, a scientific calculator now would know what to do here, because when I hit 0.24 and then I hit my times button, you see nothing happened yet. A Mickey Mouse calculator would take that 800 and add the 0.24 to it and give you 800.24, and then multiply that by whatever, and that's of course wrong. Order of operations requires me to do that first. So if you're ever unsure, just do them in little pieces, okay? Don't try to do it all in one shot. Equals 1,400. Okay? Is that one of my choices? Oh, by golly, it is. Okay? Alright, which one of these decimals is approximately equal to 3/7? Well, again, calculator's our best friend here, otherwise we'd have to do long division. 3/7 is the decimal point 428, blah, 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 blah. Does one of them look close? Yeah, this one looks close. And we were told approximately. Alright. Now we are cooking. Prime number. We didn't dwell on prime numbers, did we? What is the prime number that lies between 96 and 100? A prime number is a number that cannot be factored other than by itself times 1. Okay? So any even number here other than the number 2. 2 is a prime number because I can only factor that into 2 times 1. But any other even number I could always divide by 2, right? So 96 I could divide by 2, 98 I could divide by 2. So those two I can throw away immediately. It's the choice between 97 and 99. Just ask yourself, which one can I divide and which one can't I? 99 I know is 33 times 3, right? So I can divide that one. It's not prime. 97 I can't come up with anything. So 97 would be prime. Okay, so just work it out if you don't know immediately. Alright, 13. A 3-ounce serving of corned beef hash supplies 155 calories. Approximately how many calories will be supplied by a 5-ounce serving? Okay, classic proportion problem here. Classic. Okay, set up a proportion. 3, just be consistent with your units. 3 ounces is going to give me 155 calories, right? So I put the ounces on the top and the calories on the bottom. You may have done it the other way, and that's fine, but you just got to match over here. I got to have ounces over calories over here. So I want a 5-ounce serving, and I don't know how many calories. That's my mystery. That's what I'm calling X, okay? Match the units across. Ounces on the top, calories on the bottom, or you may have done calories on the top and ounces on the bottom. Makes no difference. Okay, cross multiply, so we're going to drop units now that we've got it. It's going to be 3x equals 155 times 50, whatever that is. Let's see, what's 155? Let me clear it. 155 times 50. 7750, is that right? Is it 5 or 50? Oh, it's only 5. All right, carelessness on my part. The unit of OZ, ounce. I saw that O and I thought it was 50. Okay, watch out. 775. Okay, divided by 3, that's how we solve this problem. So if I take 775 and divide it by 3, I'm going to get 258 point something, right? 258.3 repeating, but you see my choices over there, it's rounded off, so 258 is going to be the one. Alright, watch out. Dumb, classic blunder there. I took the O from ounce and I thought it was a 0. Okay. What's cooking with this next one? A jogger travels X miles each morning. Which of these equations represents the number of days needed to jog 200 miles? On a problem like this, if you try to think about each equation, sometimes you get lost. Just write your own equation. Let's think about it, write our own equation, and then see if it matches, or maybe we'll have to play around with it a little bit to get it to match. Okay? We're given a rate here of travel, right, of my jogging. What am I doing? I'm going X miles per day, so per morning, and we're only jogging in the morning, so per day. So X miles per day. Okay. Fair enough. And I'm going to jog so many miles per day, right? I'm jogging. And I want to know how many days it takes to jog 200 miles. Okay? X miles per day times so many days times some number of days equals 200 miles. Okay, does that make sense that that's kind of the equation we're talking about here? I'm jogging X miles per day for so many days, and that's going to give me 200 miles altogether, okay? So we need to solve this equation for days because the problem says which one of these equations represents the number of days needed to jog 200 miles, okay? So let me just kind of drop the units here to clean it up a little bit. X miles times some number of days, and that's my unknown, equals 200. So if I want to solve for number of days, I'm going to divide by X. Okay, that's kind of weird. Usually X is our unknown, and we want X to be all alone, and that's kind of a weird variable there, though, number of days. Okay, but in this case, that's what they want. X represented something else, and number of days was our unknown. So, but that's how we would solve for it. So the number of days equals 200 divided by X. Do I have one of these that looks like it fits the bill? Okay, there it is. 200 divided by X equals our days, so it would be B. Okay. Add, subtract, multiply, and divide numbers. Minus negative is our best friend. Yes, plug it in your calculator if you want to, but in this case, minus negative becomes plus positive, so all we have to do is take 176 plus 64, and we'll get 240 when we do that. Okay? Again, as an algebra teacher, I scowl at that time sign there. 3y squared times 2y to the fourth. We know how to do that. 3 times 2 is 6. Y squared times y to the fourth. That's where I add those exponents together. 6y to the sixth. That's got to be choice B. Okay? 17, factor. Oh, baby. This is one of those ones that had factors. Another test I looked at did not have factoring. So it's like, should I spend all that time on factoring or not? Because you might get 1 or 2 questions on it, but, you know, we did, of course, but it just kind of irks me a little bit that they would throw something like that at you, quite honestly, because this is a special factor here. It's a difference of 2 squares. It's that a squared minus b squared, and it factors into a plus b times a minus b, but you got to really spot the pattern there, because in order for me to fit that pattern, that's really a 2a Everybody squared, right? Because if I did that, I get 4a squared and then minus 7 squared. That's my pattern. Okay, so I know my factors are immediately 2a plus 7 times 2a minus 7. Okay? How else would you do this problem if you didn't know that? Well, I guess one thing you could do, take your, if you forget, okay, you totally forgot, take your answers over here and work it backwards. Grab, 2a minus 7, I don't know how in the world you would do anything with 2a minus 7 and turn it into 4a squared minus 49. Same thing with this one. Radical 4a squared minus 49. I don't know how you would turn that into it. But these last two, you could work a little bit and maybe figure it out. This one I could distribute and I would get 4a squared minus 14a. So I would probably reject that one because it doesn't match. But then what about this last one here? 2a plus 7 times 2a minus 7. If I did the old FOIL process there, I would get 4a squared minus 14a plus 14a and then minus 49. And when I simplified it, those two middle pieces drop away. And then I would say, aha, that's what they were asking me to factor here, right? That's exactly the same as that. Okay, you can't see them together. Come on now, see them together. I'll put a fix to that. There, see them together. Okay, so I took the answer and I kind of worked it backwards. So worst case, you could probably play around with those answers and figure out what you think the correct one is. Okay? All right, let's do 18 here. What does 18 have to say? A man estimates that 1/5 of his salary is spent for taxes, 1/4 for rent, and 1/10 for insurance. What fraction of his salary is left for other things? Well, that's simply an addition problem, right? We're not asked to calculate the salary or anything like that. We just know that we're going to take 1/5 of it for something, 1/4 of it for something, and 1/10 of it for something, right? And we want to know how much is left. So I need to take all of this and see how much it is. It's a classic, common denominator kind of problem, but let's rely on our technology that makes it a little faster. So we're going to take 1/5, 1 fraction 5, plus 1 fraction 4, plus 1 fraction 10th. Okay, that equals 11/20ths. Okay, now, careful. 11/20ths is one of the answers, right? But that wasn't the question. The question was, what fraction of his salary is left for other things, right? So he's pissing away, he's throwing away 11/20ths on nonsense for what? Taxes, rent, and insurance. Yeah, like I said, nonsense. So how much is left? Well, how much would we have altogether? If my denominator is 20, that means I've got 20/20 altogether. That would be a full amount. I need to subtract away the 11/20 to get 9/20. So 9/20 is what I have left for other things. Okay? All right. Sweet. How are we doing on time? Let me try to get half the test done on this video and half on the other. So number 19. If 2/3 of x is 48, then 1/2 of x equals. Okay. Well, that's easy, I hope. Write an equation right here. 2/3 of means times x is means equals 48. Right? I just wrote an equation. 2/3 of x is 48. Solve that little problem. How do I solve that little problem? Well, I got a fractional coefficient. I'll multiply by the reciprocal. Cancel, 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 cancel. I'm just going to have x equals 48 times 3 and then divide by 2. 48 times 3 divided by 2 equals, what do we get there? 72? 72. Okay, that's x though. Hold it. Hold it. Half of x is the question. If 2/3 of x is 48, then half of x would be what? So now I got to take half of that 72. Okay, always answer the question being asked. You could be doing so good and get that 72 and be so proud of yourself and circle 72, which is one of the answers, of course, but that's not the question they asked. They asked a slightly different question. So watch out, okay? All right, one more problem on this video and then we'll pause it. Okay, we better know this one. Which of these values is that? Negative outside the parentheses, 2 to the 4th power. Negative's minding his own business, 2 times 2 times 2 times 2. So it's going to be a negative number, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. It's going to be a negative 16. Okay, now the ones I did in class though were slightly different. I said if it's like this, negative 2 in parentheses to the 4th, then it becomes a positive 16. Okay, and then I just showed it with no parentheses, and I said that's a negative 16, right? Now this is slightly different. They kind of did the old sneaker rule on me there. They put a parentheses in, however, the negative's outside the parentheses. See that? Okay, so the negative is not part of the exponent process, so it's slightly different than the two examples I gave in class, but also it would be negative. Okay? Okay. That's it for this one.